And we are switching to our next speaker. Our next speaker is Lucas Santos. He is a cloud developer advocate at Microsoft. He is working as a cloud advocate at Microsoft. He's a technology lover and since 2011 works with highly available and scalable applications. Loves to teach and learn. Writer of Kubernetes, everything you need to know about container orchestration. Granted the title of Google Developer Expert. Microsoft person with Google Developer Expert. When can you see that? That's dope. He is member and contributor to the Nodejs Foundation, helping to translate the Nodejs runtime documentation to Portuguese. And also is one of the core members of several awesome communities such as NodeBR, GCCP, Vue.js, Spain probably, TypeScript BR, Node School SP, Training Center, and ABC Dev. Homebrewer in free time loves music and games. We spoke about beer so much, so we got Homebrewer. Everything you want is here. And Lucas will speak about Node.js and AKS equals #DreamTeam. Lucas, the fan is yours.
Hey everyone, I told you loved beers, so here I am. Now let me just take this slide off because my slides are about beer. So no, I'm kidding. Hey everyone, my name is Lucas. This is our talk about Kubernetes. So basically, what we're going to do here is I'm going to introduce you to Kubernetes for those who don't know. I already gave the disclaimers on my other talk on the senior track. So I'm going to save them for a bit later because I have a slide specifically for disclaimers on this talk. So let's go on. So talking about me, I think I was pretty well introduced. So I'm just saying my name. My name is Lucas Santos. I'm a cloud advocate at Microsoft. So this is my email if you want to send me something. I'm always available to answer some questions, anything. All my social networks, or at least most of them, are on my website here, lsantos.dev. The slides for this presentation, I forgot to upload them on the platform, so they will be on my Twitter as soon as the Q&A ends. So as soon as I finish answering all the questions and everything else, I will be posting the slides over there. And I have a few disclaimers. So this is the slide I was hoping to talk about. Well, basically, there are some disclaimers. I've seen that a few people are taking several advanced content. So this is a junior tutorial, right? So I'm going to introduce, this is a beginner tutorial. I'm going to introduce you to Kubernetes. I'm going to tell you how it works, not in depth because Kubernetes is very huge, but I hope you all to understand Kubernetes. And the second disclaimer is that despite this is a Node.js focused event, and you'll be seeing like Kubernetes, what the hell am I talking about Kubernetes? But this talk is more focused on containers and Kubernetes because even though I know that we all love Node.js, I love Node.js, I love TypeScript, JavaScript, and I love all of those things. But I think it's important for every developer to know where your code is going to run. It's important for you to know how it's going to be running. It's important for every developer to know a tiny little bit of infrastructure and a tiny little bit of DevOps, just to understand how all the codes are going to be executed and how you can make your code even better and even faster to run in this optimized environments. Okay, so this is why I am bringing you with AKS, and this is why I'm bringing you with Kubernetes today. Okay, so the whole goal of this talk for me is to show you how a distributed application, a distributed system looks like, and how you can deploy it using Kubernetes, and how you can scale endlessly, almost, by using AKS and virtual nodes. So there is a demo. I'm going to be showing code. There's not theoretical only, but that's very cool. And I promise you're going to like it, right? So let's going to start. What is Kubernetes? So I'm going to talk about Kubernetes a lot. So you need to know what Kubernetes is. Basically, if you already work with Kubernetes, if you have been working with Kubernetes a lot, so leave some comments in the chat. I would love to hear them, and I would love to answer them. So if you want to talk, just let me know. Kubernetes is defined as a container orchestrator. It was created by Google in the 2000s, and it's the third of a series of projects. So I don't remember the order correctly, but I think it started with a project called Omega, and then it became Borg, and then Borg became Kubernetes. And Kubernetes has been around since 2000, and it's used by Google, and it's used by a lot of companies like Microsoft and Amazon and so on. And it's an orchestration tool. What is an orchestration tool? Actually, when you deploy several applications into a microservice environment, you take a huge problem on this, right? So I'm going to talk about more of this later, but what Kubernetes does is it manages the containers for you. So the first open source version was released in 2015. So we spent like 15 years with Kubernetes being a closed source version until the world actually needed something to do with it. So it's one of the best open source communities we have. It's very active. It's now maintained by the CNCF. CNCF is the Cloud Native Computing Foundation, and it's open source. So it has a repository on GitHub. It's github.com/Kubernetes/Kubernetes. So we came to solve the problems with distributed software in general, login, errors, and so on. And what are those issues, right? So the first problem we have when we are working with distributed systems, that the communication is a mess. So when I'm gonna show you this slide first, and I'm gonna get back to this. But this is a slide I get from Nginx Conf, and you can see it's pretty complex. This is a simple orchestrate. This is a simple microservice architecture, simple. But you seem to have like an API gateway. This API gateway communicates with several other systems, and other systems communicate with several other systems. And these things, every one of those things can communicate between themselves, like these REST APIs over here, and can communicate with third-party services like Twilio or Stripe or SendGrid, like here, right? So we have like different applications for different things, and these applications actually go from communicating with their peers right by side and with external apps. So that's kind of complicated, right? So this creates a communication mess because you don't know who is communicating with whom, especially if you have like a lot of microservices running on. And these can give you esoteric error messages. So basically, distributed systems often pop errors, especially if you're using APIs that have been calling other APIs. So there's an API that calls another API that calls another API, but the third API has an error. And then the first API returns this error as being as its own. So you don't know if the error occurred on the first API, on the third API, or anything in the middle. So this is something about software architecture in general, of course, but this is something that, despite Kubernetes can't solve this directly, Kubernetes provided tools and the platform to do so. Auto-scaling is another problem. So when you have auto-scaling, you need to, when you do manually auto-scaling, that's a very boring stuff to do because you have to manually auto-scale all your services. And Kubernetes provides the tools and actually does this for you. Tracing logs, what we call deep tracing. That's exactly the same thing I told you about the esoteric error messages, but with logs. So if you want to log everything that's happening inside your application, inside your distributed services, it's pretty complex. And Kubernetes, despite not having a native way to do this, there are pretty cool plugins and pretty cool tools like Jaeger that allows you to do so. And this runs on Kubernetes, right? So that's very nice. Well, networking, routing, and actually networking in general, it's managed by Kubernetes. You don't have to know anything about service discovery. You don't need to know anything about DNS services. You don't need to know anything about proxies. You don't need to know anything about ingresses and nothing. Kubernetes manages all the internal and external communications for you. So this is very simple for the perspective of the developer, right? You don't need to be a sysadmin, but it's nice to understand those stuff. And the last topic is actually the distributed service management, because from the sysadmin point of view, the sysops point of view, this is very difficult to control from a single place. So if you have like 10,000 of services and 10,000 of servers created by someone, and you have to manage them in a single place. This is often done by using Python scripts and Bash. So it's not very cool. And now Kubernetes allows you to manage this from one single place. So this is the simple architecture of my screen is on the right side. I have to keep stopping, pointing this way. I'm going to point this way. So this is the simple API that we have. So basically, we have several services divided by domain. So we have passenger, web UI, passenger management, driver management, and so on. And this is something that can be complex over time, right? So software gets complex over time and not because of the amount of code on this. Well, this is a wrong animation, but this is how container evolved over the years. So first we had libraries and VMs. This is the representation of a VM. And I'm telling you this because it's very important for you to understand how things came to be. Kubernetes didn't just emerge out of the blue. It had It evolved from several other technologies. And you need to understand why this thing happened, and not just because Kubernetes needs to exist. But this is the this is basically what a VM does. So we have a kernel and libraries and have several apps running inside a machine that's running inside a machine, and everything is managed by the host OS. They get the host OS, and you have guest OSs inside. So every time you have like several machines, you would have like one Windows and one Linux inside this machine entirely. So this is very heavy, and this is actually very slow. So if you have worked with VMs before, VMs can wait like several gigabytes, and they can take up to like 5 or 10 minutes to spin up. And well, who doesn't like VMware, right? Then came containers. Containers are not were not created by Docker, right? Containers already existed in the Linux system, but Docker kind of make it democratic. Everyone could use it. I cannot spell the word. But basically what containers do is that they create a wrap around the applications where they have the libs and as well. So you don't have to spin up the whole operating system. You have just to spin up the container with their libs. So they're going to be sharing libs with the operating system, and the hypervisor, which was managed by the VM driver, like I don't know, VirtualBox or something, is now managed by Docker in this case. So you have Docker engines, and the Docker engine manages all the system calls to the kernel and the host operating system. You don't need to, spin up Windows again with all its drivers and everything else. And then came Kubernetes. Kubernetes you can imagine as being a wrap around the wraps of containers. So basically, Kubernetes sits on top of Docker. It runs Docker containers inside it. Not only Docker, but it can run other container engines as well. And it manages them. So it's similar to what Docker Swarm does, but we had this question in the other track. It's very nice to repeat it here because it's something very cool. Docker Swarm does almost the same thing, but the feature-wise they are different. So Kubernetes is more like a production ready for heavy stuff, and Docker Swarm I would use it to smaller stuff. With Kubernetes you can do things like this. So this is actually a dashboard presented in Kubernetes, created using Kiali, which is a tool, an awesome tool created by Red Hat that allows you to create these service mesh maps on your systems. And Istio, which is a Google plugin created by, it's a plugin for Kubernetes created by Google that allows you to create and manage service meshes. So you can have HTTP traffics, you can see the links, you can see the maximum traffic time, you can see the TCP requests and so on. So it allows you to do this, okay, and fairly easy if you would ask me. But how it works? Kubernetes is based on clusters. So you have a master node, and you have several worker nodes, or process nodes. We usually call them kubelets, but you can call them worker nodes, because now that there is Rust, there is another name for this. There is the crustlet. So in general, the master node manages all the worker nodes, and the worker nodes are the ones that actually execute your code. And why is this a thing? Because instead of having one single huge machine, you're going to have like several smaller machines that's going to behave like a huge machine. So Kubernetes takes advantage of this stuff, because it's very, very fast to scale. So you can scale the number of nodes, and you can scale the applications inside those nodes. So if you have the resources, you can scale basically endlessly. So it's very simple. It's very easy to understand, right? Now let's zoom in. Imagine we're zooming in into the master. So the Kubernetes master node is something that actually takes care of all of the managing inside Kubernetes. It has the scheduler service, which takes your application, your Node.js application, or whatever application you are trying to spin that up, your container, and decides whether it goes to this worker node or to the other worker nodes. So it needs to manage the resource, like CPU and memory. It has to manage volumes. It has to manage APIs, networks, and so on. So it creates like this control plane, we call it, to understand what it's going on. It has an API server. All the communications are done with Kubernetes is done through an API server, a simple API server, a REST API using a JWT token. It's very, very simple. It's very, very cool, because it is not that complicated like so many other stuff that we have. It has a node controller. The node controller is the one that manages if the nodes are behaving correctly. So if a node is up, it's running up. It's lacking CPU, it's lacking memory, and so on. And it has a state storage. So the state storage is provided by etcd. etcd is a distributed database created by CoreOS. It's very nice. It's a key-based value. It's a key value store. So it's very simple. It's very fast. And it uses the etcd state storage to manage all the states in the cluster, right? So it's very nice. And now zooming in into the worker nodes, the worker nodes are pretty simpler, because they have only the kubelet. Remember that I told you what is a kubelet, right? I told you that the node controller receives like metrics from the nodes, like CPU, memory, and whatever is running inside them. And these metrics are given by the kubelet. So the master knows everything that's running on inside the nodes because of the kubelets. The kubelets are watchers and watchdogs that takes all the information inside the machine. So this is a virtual machine. This is a machine. This is a server that's running inside the infrastructure. This is also a server that's running inside your infrastructure. So you can have like Windows machines, you can have like Linux machines, you can have TPUs, you can have GPUs, you can have like several nodes inside one single cluster. And besides the Docker engine that runs inside every kubelet, we have a proxy. And this proxy is responsible for the network connectivity. So when you have to, when you're trying to communicate from one node to another, this is the proxy that's going to be done. That's going to be doing this thing. So basically, this is why the proxy exists. And inside the kubelet, there is your app, whatever you want to call it, right? And we have kubectl. Well, kubectl is one, in my opinion, one of the best tools, best CLI tools ever, because it's simple. It's the single point of control for all Kubernetes clusters. It's just a management tool that allows you to communicate directly to the API that the master provides. So basically, it is a simple way to communicate between the API. It's very reasonable, and it's very straight to the point. So the syntax is very simple. It's based on config files, so you can actually set up in different hosts and different machines just by having a kubeconfig file. That's pretty nice. And it's default to all Kubernetes clusters. So every Kubernetes cluster uses this. So it's very simple. So this is the like zoom out of the control plane, a typical Kubernetes control plane. So this is the user. This is like the sysadmin or the DevOps or the developers, whatever. And this is kubectl doing the interface between the users and the Kubernetes cluster. So this is the server. This can be like a dull server or a hack like anyone else, any others, or it can be a cloud managed cluster. And I'm going to talk about. And you have kubeconfig files that allows you to interact with API servers within Kubernetes. And this Kubernetes reads and writes into this Kubernetes APIs reads and writes into the etcd cluster, which is actually it doesn't need to be a cluster, it can be only one. It allows you to write on the state storage, and these are the resources. So the API manages all those resources for you. And in Kubernetes, actually, one of the best things that Kubernetes have is that Kubernetes is based on declarative files, right? So declarative files is something that to understand. So to give an example, we have imperative languages, programming languages like Nodejs, like TypeScript, like whatever. Nodejs is not a language, like JavaScript, like TypeScript. You have in these kinds of languages, you have to actually say to the computer what you want it to do. So basically, you are giving orders to the computer. And you have declarative languages like SQL. And SQL, you don't tell exactly what you need the computer to do. You just tell it, select everything from table X. And then it's going to be some magic, and you're going to have the data. So basically, this is what Kubernetes does. Whenever you have to create anything inside Kubernetes, basically, you can use these manifest files. Those manifest files actually declare what you want to do. So I want to create a deployment. These are concepts in Kubernetes. I'm not going to explain them because there's not enough time for me to explain everything. But you have a deployment, you have like a pod. A pod is a abstraction of a container. You can do everything here, and then you just put like Kubernetes create and pass the file, right? So this is cool. But there is the problem. When you're talking about installing Kubernetes alone, even if it's very good, but the installation is very complex. It's very complex to install Kubernetes into a bare metal server. And sometimes it's like a mess like this. So you don't understand what's happening, but things work, but you don't know why. So basically the difficulties are the network discovery. Sometimes you have to set it up by hand. It's very complicated. The other stuff is the clusterization. It's very complicated to clusterize stuff on a bare metal cluster. Proxies, networks in general, DNS, load balancing, volumes, because you need to spin up the cluster and you have to give it volumes to run on. And now we have something that we call managed services. Looking at these huge companies like Microsoft, notice that, well, I could sell this as a managed service. So the first one that actually did this, I think, was Google, of course. But now we have three types of services. We have AKS, which is created by Microsoft. It's the Azure Kubernetes Services. We have GKE, which is the Google Kubernetes Engine, and EKS, which is the, I forgot, Lasky Kubernetes Service. I think it's been a while since I don't use it. But this one is provided by Microsoft. This one is provided by Google, and this one is provided by Amazon. So they have differences. I'm going to talk about AKS in specific here. I'm not going to talk about the other two. But why should we move to the cloud, right? So it's faster because it's faster both to run stuff and both to and actually to create stuff, because you just need to issue some commands and things are done. You don't need to be actually managing stuff. It's more efficient because there is actually a lot of people looking into it to be efficient, because if the cloud is not efficient, it's not efficient not for any customer, the cloud, it's a very sensitive environment. You need to know there is a correct balance of things you should do when you run a cloud environment. You have to do less manual work because it's way faster to create stuff just issuing some commands and things just run. You don't have to provide maintenance, especially this because, you know, physical servers. And it has more equipment variety. So if you want to spin up a 64 gigabyte machine that you might not have, well, I'm sure that Azure has it. If you want to spin up a huge 3 teraflops supercomputer or something that you might not have, probably some cloud has it. Well, I think the best example is for machine learning. If you want to, you know, spin up a Kubernetes cluster using to use GPUs or TPUs, which are tensor processor units, you might not have these kinds of hardware, but all the clouds, most clouds have those kinds of software or these kinds of hardware. So you have more variety in your equipment, right? And why did I choose specifically AKS? Because it's easier, I think, from the others, and it's pretty simple. There's not much configuration. It's pretty straightforward. There's a lot of documentation. It's pretty extensive, and it's being maintained by a lot of people, including me. So we actively maintain the documentation for AKS all day, all night. And we don't pay for the master node. This is what I was talking in the other track too. There was a question about this, but every different Kubernetes provider has a different pricing in general. So some of them charge for the master node as well as the nodes itself. But some others, like AKS, they just charge you for the amount of resources that you're running, which means that they don't charge for the master node. They just charge you for the nodes because they are VMs running inside Azure. So this is the same, I think, for GKE as well. It has routing out of the box. There's something called HTTP application routing, which I'm going to be demonstrating on our demo. It has cluster auto-scaling, which means that whenever your nodes run out of CPU or memory, Kubernetes will auto-scale them to create another node to run your containers inside it. You have to bear in mind that the machines are not infinite. You can have a limited amount of containers for each machine, for each node. So when a node runs out of resources, it has to be created another one. You have to create another one and then another one and so on. And it has something very nice called virtual nodes. So what are virtual nodes? Virtual nodes is one of the best things that ever existed. So imagine you have a Kubernetes node and you start deploying applications on this, right? So you're going to start deploying all the applications and they're going to fill up your node, right? Because as I said just now, there's a limited number of containers you can spin up in your application inside your VM, right? So this is going to be filled by applications. I'm not going to wait for this to end. But when this is all filled with applications, the next node, the next application you upload over here will not succeed because it doesn't have enough space. So the cluster will auto-scale, but it takes a while for the cluster to auto-scale. So virtual nodes are nodes that are already scaled, so you can deploy them on the run. So while these things auto-scales, you can just pull all the stuff to virtual nodes, and they don't need to scale because they're virtual. They are a pool of nodes that Azure has that you can share stuff on this. So it's awesome for scaling stuff that actually does scale faster, a lot faster. And this is charged by the second of usage. So once you can do this, you can just like move. Let's imagine we have a queue like RabbitMQ. And this RabbitMQ is getting very filled up with stuff. And you want for every message, a new node or a new application goes up, take the message, process it, and then dies. So for every message, there's a new box of those that's going to be spinned up. So once there will be like 1,000 million messages, and then your node is going to be filled. So you can use virtual nodes to have, this is one of the examples I'm going to show you. You can use virtual nodes to have all the messages being spinned up inside virtual nodes, paying only by the second of usage, and then dying. You can also take these applications out of the virtual nodes and put them back on regular Kubernetes nodes. So this is available for you to do. It's way harder to do it, but it's also available for you to make it work. So now I'm going to show you a demo. Unfortunately, I didn't have enough time to code this and run this.
5
so
minutes.
I'm just going to. Oh, okay, 5 minutes.
Yes.
Okay, awesome. So I'm just going to run this off. First of all, we need to. You see, this is very fast. We need to register some providers here in Kubernetes. So actually in Azure, to allow the virtual nodes to be enabled, right? So you just make this run. So things are going to be run, and providers are going to be registered. You use this provider list. If it's registered, you're good to go. This is on the tutorial, right? So here I'm just creating a new cluster. As you can see, I'm testing 3 things here. I'm testing, the first thing is the creation of node. I'm showing you how easy it is to create a AKS cluster. I'm actually showing virtual nodes and then HTTP application routing. It's a 2-minute video, so it's very simple. I'm just choosing the size of my nodes, the amount I want from them. I'm enabling the virtual nodes here. So I enable them here. Now I'm enabling this here. So they have authentication. This is all the network stuff that we would need to do manually. Now we don't need to do it manually anymore. I'm just enabling the HTTP application routing. HTTP application routing is what allows us to deploy an application and makes this available to everyone, like a proxy or a server. You don't need to configure anything else, right? So tags, review, and create. So stuff is going to be created. It's pretty simple. It's pretty fast. The deployment's being done. It takes a while. When it's done, I go to the resource. So this is the virtual nodes. This is the Kubernetes service that I have spinned up. This is how simple it is for you to connect to the stuff. So basically, you just run the credential stuff, and it's going to be automatically configuring your kubectl. This is the beauty of having one single default CLI to manage everything else. So you can integrate it with several stuff. So let's go back a few seconds. This is the application I'm going to be deploying. So this is a deployment of a image called Party Clippy. It's simple. So you can see that I have a deployment here. We have a service that allows me to make it available for the cluster, and we have an ingress. The ingress is what makes available for every other application in the web. So this is the DNS service. This is the DNS address here. And this is everything we need to deploy a full application. So I just go kubectl, K is kubectl, my alias, apply, go on with the file, and you can see that this DNS zone has already been created. If I get refresh, you'll see that we have a created DNS zone that Kubernetes actually created for us. And I needed to do anything. It's out of the box, right? So I go to the address on that DNS zone. So Party Clippy, you see like things are working. I can get the deploy, I can get the pods, and I can scale stuff. So you can see that I will be scaling this to 30 replicas. Once I do this, you will see that the pods will start to run. But there is something that is happening that it's proposable. My CPU is not sufficient, as you can see here. My application needs an amount of CPU, like requests 250 millicores of CPU, but it doesn't have the amount of, my node doesn't have the amount of CPU to run it. So I can't. So I reached that scenario here where all my nodes are complete. So what do? Do I expect do I just wait for the node to scale? No, I won't. I will make it a virtual node. So I'm just going to delete it all. Basically, now we're going to make it on the V nodes. So the only thing that changes is that now the V nodes need to have a 100 millicores requests because it's virtual. It's a known limitation. And this, so we have to make a node selector and tell, well, this is the virtual node, and we need to deploy it on a virtual node. Okay, so you can do the same stuff if you need to deploy on a GPU or a TPU or something else. I just do the same stuff, and now we have a partially PV node here. I'm not going to access this application on the browser because it needs a few other network configurations to allows you to work on the browser. And you have to know that it's running on a virtual node. Now I'm going to scale that up again to 30 replicas, and you will see that it's not going to blink. It's just going to scale that thing up forever. And there are a few pods ready, and there's a few pods creating. So if I will do like get deploy, you will see that the deploys are going to be created. So there is like 25, 27, 29, and then 30. And you will see that everything has been created and all the pods are running smoothly, right? So this is it. I showed you in just this 2-minute video how we can create an application, how the HTTP application routing works, because you just need to make it simple. And I showed you virtual nodes, and you can now create an application, a full application, upload it to virtual nodes, and that's it. So there's a few known issues to this. The resource and request limits I told you about. This is not actually an issue, it's a limitation. You have to put resource and request to 100 millicores or 0.1 millicores. Networking, you need to do manual configuration. Virtual nodes don't actually work with HTTP application routing. You have to upload your own ingress controller. This is why it's the best approach is to use like RabbitMQ consumers for background processes, things that don't need to be exposed for the internet. Because if you do this, you don't need to configure network. The local network will work, but the external network will need to be unconfigured. So it's really simple to do it. In the references over here, there are. I'm going to take this. Leave it a bit here so we can take a picture, but the slides will be on my Twitter. In this slides, there are a few workshops on AKS, the virtual nodes documentations, and I forgot to put over here, but I'm going to put on the chat. There is this amazing scaling demo on the Azure training. So this scaling demo actually does exactly the same stuff I just told you. So it has a RabbitMQ consumer, and this RabbitMQ consumer is going to be scaled up to like 300,000 pods, and things are going to be working seamlessly, right? So I'm going to put this link on the chat here in a few moments. And well, this is what I wanted to show. It was a pretty simple explanation. It was a very beginner tutorial, but I hope you all understand how to use Kubernetes and how to deploy your Node.js applications on the Kubernetes clusters, so you can, take advantage of everything that Kubernetes and the infinite scalability that the Kubernetes can offer you. These are my social networks. Again, if you want to get there, follow me and ask me anything. I will be there. I am always eager to ask and answer any questions. I love to learn. So come on, check on me over there and send me a message. So that's it. Thanks, everyone.
Thank you, Lucas. So during your presentation, we decided in the chat that you are a boss. So you need to tell why we decided that you are a boss. After people will stop shutting me with their emails, I will send select invites to everyone. Thanks a lot. That was an amazing presentation. We are waiting you on our panel discussions, and I'm sure that there will be a lot of questions to you. And